Hello everybody. So we're going to go ahead and get started with our Unit 2 review. This is going to be a very long video just because we're going to really go into detail about what some of the free response questions are going to look like and then how to get prepped for those multiple choice questions as well. The review itself, the exam itself is going to have 8 multiple choice questions, okay, and you should be able to do them without the calculator. And then it says that we have 1 free response question without the calculator. That is incorrect. It's actually going to be 3 free response questions without the calculator. These are just going to be basic solving absolute value equations and inequalities. And then we do have 1 free response question with calculator use, but that free response question actually has 5 parts to it. So it's pretty in-depth. So we've got quite a bit to cover. I want to be sure that we are able to solve these types of questions here. And so when we do this, we want to make sure that we follow the first step as to isolate the absolute value. So we have 2 absolute value of b minus 1 plus 2 equals 8. So I want to isolate this first. To do that, what we're going to do is we're going to subtract 2 from both sides. And I'm going to be left with 2 absolute value of b minus 1 equals 6. I still don't have this absolute value isolated yet, but I will after I divide both sides by 2. Get rid of that there. I get the absolute value of b minus 1 is equal to 3. And I'm going to circle this. It is not our answer, but this is the isolated form of our absolute value. So we're done with step 1 here. For step 2, we can solve the first case. Our first case here, which we're going to do, we're going to start with the isolated absolute value, which is the absolute value of b minus 1 equals 3. I can drop the absolute values. I have b minus 1 equals 3. I can add 1 to both sides, and I get that b equals 4. And this is one of our answers. Okay. For case 2, this is super important here. For case 2, we start with the same isolated absolute value. Okay, that absolute value of b minus 1 equals 3. But we're going to apply the KISS method, okay, where we keep what's inside the absolute value, which is b minus 1. We switch the equal sign, but when we switch that equal sign, it just stays as equal. And we switch this 3 to a negative 3. We then want to isolate b. So what we're going to do is we're going to add 1 to both sides. And I get that b equals, well, negative 3 plus 1 is going to be a negative 2. And we've completed step 3 and 4. And then we want to graph. For our graphs, as long as our values are in order, we're okay with where we put them on this number line. For instance, my 4, I'm going to put 4 here, and it'll be a solid point. There's no arrows because we have just an equation. It's not an inequality. And for my negative 2, it does need to come before the 4 in a number line, right? Because 0 would need to be in the middle. And we have our solid point here. Okay? And that's the situation that's happening on this one. All right, let's go ahead and move on. So I want you to be able to do the exact same steps with the exact same skills on this question. If you have any issues with this, please let me know. I'll be more than willing to help you guys out. Let's move on. So this is a question for me here, so I'm going to work this one out. Same skills. So I have the absolute value of a plus 5 minus 4 is less than or equal to 7. I want to isolate the absolute value, so I'm going to add 4 to both sides. I get the absolute value of a plus 5 is less than or equal to 11. This I'm going to circle. It's my isolated absolute value form, which is important. So for my first case, I'm going to have the absolute value of a plus 5 is less than or equal to 11. To solve this, we just drop the absolute value. I have a plus 5 is less than or equal to 11. We then subtract 5 from both sides. and I get that a is less than or equal to 6. This is one of our answers. So we've isolated, we solved for the first case. To get that second case, we start with the same isolated value, right? Which is the absolute value of a plus 5 is less than or equal to 11. But we're going to apply the KISS method where we keep what's inside, the absolute value the same, a plus 5. We switch the inequality to now it's greater than or equal to, and we switch that 11 to negative 11. We then want to subtract 5 from both sides, and we get that a is greater than or equal to negative 16. So on our number line, I'm going to put negative 16 on the left over here, and it's going to be a close point. Okay, it's going to be a close point, and we are going to be going to the right here as we're talking about all the values that are greater than negative 16. And for our 6 part, we're going to put a 6 here, and we're going to go, it's going to be a solid point because it's equal, and we're going to go to the left because it's all the values that are less than or equal to 6. This is what our graph here would look like. Okay. Let's go ahead and move on. So I want you to practice the same skills here. Heads up, be very careful with the inequality. The last one was greater than and less than or equal to. This one is not. This doesn't have equal. So while it doesn't affect too much of the math, it will affect your graph. So just be careful with that one. And let's do another one here together. So I've got 10 absolute value of n plus 1 is greater than or equal to 90. So I want to isolate this. To do so, I'm going to divide both sides by 10. And I get the absolute value of n plus 1 is greater than or equal to 9. Pretty straightforward. I'm going to circle our isolated absolute value. For our first case, we'll do the absolute value of n plus 1 is greater than or equal to 9. I'll just drop the absolute value. So n plus 1 is greater than or equal to 9. We will then subtract 1 from both sides, and I get n is greater than or equal to 8. For our next case, we'll take the same isolated absolute value, that absolute value of n plus 1 is greater than or equal to 9, but we need to apply the KISS method, so we keep what's inside the absolute value, which is at n plus 1. We switch the inequality, which is now less than or equal to, and we switch this 9 to a negative 9. We then want to subtract 1 from both sides, and we get that n is less than or equal to negative 10. All right, so let's start graphing at 8. And we'll put 8 over here. We'll have a solid point, a closed point, because it's greater than or equal to, and we're talking about all the values that are greater, so we go to the right. And then at negative 10, we'll have a solid point, which I want all the values that are less than or equal to, so we'll go to the left here. Okay. Pretty straightforward. I think all these 3 questions are very similar for the ones that I've done. This one here is yours. Hint on this one, you're going to be dividing by a negative number. Remember, what does that do to your inequality symbol? If you get stuck, please let me know. So let's look at some questions like this here. It says, which of the following is a valid order of transformations that when applied to f of x equals the absolute value of x will result in a function. So in other words, we just need to identify the transformations here. So the transformations, first one we see is this 1/2. And I want to make something very clear here. With this 1/2, we can have a vertical stretch, okay, by 1/2. Another way we can say this, and I want to make this very clear here, guys, another way that we can say this vertical stretch by 1/2 is we can talk about it as far as a horizontal change as well. So if we're vertically stretching, that means up and down we're getting longer, right? We're stretching. Okay, we have a vertical compression because it's getting skinnier. Vertical compression by 2. Then you're probably wondering, where do I get this 2 from? Okay, well that 2 is coming from this 1/2. If we switch this, if we take the reciprocal of that, the reciprocal of 2, I'm sorry, if 1/2 is 2. Had this been a 1/3, well this would have been a 3. Had it been a 1/4, well this would be a 4. Okay, this is same skill, just a little different way of seeing it. As far as what's happening with that x minus 2, you guys are already very solid on that. We know we're going to go 2 units to the right. We know that it's the opposite of what we see there because we're setting x minus 2 equal to 0, and we'll get a positive 2. And then lastly, we have that plus 5, so we would go 5 units up. So I really want to stamp this horizontal compression. If you have any questions on that, guys, send me a message on Teams or ask me during class. This is your question here, guys. I want you guys to be able to do the exact same thing I did on the last problem. I know you guys will do well on that horizontal change, you'll do well on that vertical change, but I want you to be very careful with what happens to that 1/4. Tell me what it happens as far as vertically and horizontally. Okay. All right, so let's look at this one here. This is an interesting question. We've discussed transformations, and we've always looked at what happens to the vertex, but now we're going to be observing like what happens to a point other than the vertex. Okay, so I have this point P here. Okay, I'm going to go ahead and circle him here, and I'm going to do the top part here. It says a vertical compression of 1/2. So when we take a vertical compression, okay, that's our up and down. Okay, our P value here, okay, is at 2. Okay, and at -2. And this is important. So it's at -2, 2. If we take a vertical compression of 1/2, we're changing our up and down. Okay. In other words, we need to take this -2, 2, but our y value is what's changing, and we're going to multiply this by 1/2, which equals -2, 1. So really our point is going down here. Okay, so we shifted down. This is what's happened with this first. So it's going to go down 1, and that's because of the vertical compression. It's kind of squashing it. When we squash the graph, that point is going to move down. Then it says we have a reflection over the y-axis. So that reflection, well, we see the point here is 1, 2 units from the equation, I'm sorry, from the y-axis, which means that respectfully, we have to be 1, 2 units away. Okay. So we're over here now at 2, 1. That's our reflection. We just swapped our value. You can also see here we had a negative, and this just becomes a positive. Nothing too crazy there. And then lastly, we're going to go 2 units to the right. So we just stay on the same point, but we're going to go 2 more units. 1, 2. And now we're going to be at 4, 1. So nothing too crazy there. I want you to try this with the next set of transformations. I want you to start all over again. Then you're going to take a vertical compression of 1/2, same steps. Okay, this is practice here. Take that reflection, and then I want you to analyze the horizontal shift of 4 units and tell me what happens there. Okay, this is your problem. On this one here, guys, I'm not going to do anything here. I'm giving you a graph And I want you to identify all the true statements. Tell me, is the range going from negative infinity to infinity? Okay, is my y-intercept at 0, 5? And then is my vertex at 3, 2? So this is analysis of a graph. We've done this for like 3 weeks already. Go here. I'm going to tell you one or more of these may be false. Okay, so be very careful with what happens here. Let's go ahead and move on. So this question says, given the absolute value inequality below, and so with the one that's below here is this inequality. It says, which of the ordered pairs, which is the 4 answer choices here, is in the solution region? In other words, which one of these is in the shaded region? Okay, so what I've done here is I've created a graph in Desmos, and I'm looking at the shaded region. At -2, 0, this one is not in the shaded region, so this is no good. At -4, -2, nope. 0, 2, yeah, this looks like it could be it. Let's see, 0, -2, this guy is not in the shaded region, so this guy is a no. So yeah, our answer here is 0, 2. We're just looking for what is in the shaded region, which satisfies the equation. Okay. You guys have the same scenario. Your equation is a little different, and your answer choices are different. So you're going to want to use Desmos to analyze this. Find out which one of these 4 points is in the shaded region. All right, let's go ahead and move on. So this question here, guys, we've actually seen this question in class. I want to make sure that we really stamp the equation we need to use on this. We're given this scenario says the length of a standard basketball court can vary from 84 feet to 94 feet inclusive. So when we did this, we actually created a number line, right? We know that we're going from 84 feet to 94. Then I want you to think, like, when we use the equation that we're supposed to be using, that absolute value of x minus c is less than or equal to r, we need to identify our central value and our range value. Okay, our central, hint, hint, is right here in the middle. Okay, this is our central value. Our range is the distance from the central to both ends. This is our tolerance, our variance here, right? This is our plus or minus. So you're going to come up with this, and all I want you to do is come up with the equation. So you got to think, where's my center? What is the distance of the range? And give me that equation. Okay? Let me know if you have any issues with this one. All right, this question. It's a very interesting question here. So it says, for what value of k does the value of so what value of k, there's a little typo here, would the equation, absolute value of 3x minus 1 plus k equals 7 be no solution? So with absolute values, we can have no solutions, and I'm going to be very clear here. If I have some absolute value of x equals a negative value. The reason for this, guys, this is going to be no solution. Any value. If we have the absolute value of x equals, like, let's say -2, this is no solution. Why is this no solution? Well, we can never take the absolute value of x and it would give us a negative number. Remember, the final value within the absolute value will have to be positive. So it's impossible for this to give me a negative. So let's check this out. Let's test some of these values here. If I have 3x, the absolute value of 3x minus 1, and I plug in this 1 first for k, if I have a plus 1 equals 7. Okay, to solve this, we would subtract 1 from both sides, and I get the absolute value of 3x minus 1 equals 6. This will give us a solution. Okay, I don't need to solve it. I know that we will get an answer. We can stop here. So it can't be 1. What about 5? Okay, let's try 5. If I do the absolute value of 3x minus 1, okay, plus 5 equals 7. I can subtract 5 from both sides, and I get the absolute value of 3x minus 1 is equal to 2. Well, 2 is positive, so this will also give me an answer. It's actually giving me a fraction. I don't care that it's a fraction. Actually, it wouldn't be a fraction. It would be actually a whole number, which still works. But either way, we don't want to do. We can't do this. We're going to get some true solutions here. For the next one, we can try the absolute value of 3x minus 1 plus 7 equals 7. If we were to work this out, we'd subtract 7 from both sides, and we get the absolute value of 3x minus 1 equals 0. This is also true. We can get this. We can get that the final absolute value here would be a 0 value. That's a real number there. So by process of elimination already, we know that the answer has to be 8, but let me prove it to you. If I put the absolute value of 3x minus 1 plus 8 equals 7, if I subtract 8 from both sides, I get the absolute value of 3x minus 1 equals negative 1. This negative here makes all of this no solution. When I have my simplified absolute value, or my isolated absolute value, if it's equal to a negative, that's going to be bad. And we'll get no solution. It's impossible. So we have 8 is our answer. Okay. A quick way of analyzing this is you could have just looked at your K, looked at your answer choices, and been like, I just need to find a value that's bigger than 7 on this. But that's kind of like working backwards. It's more like an ACT strategy there. But we can talk about that later if you have questions. So I want you to analyze this one here. Don't let that negative 2 fool you. Test it out. What happens when you put a negative 2 and you try to isolate the absolute value? Okay, and we're looking for which one of these answer choices makes, or which answer value for K would make this no solution. Okay. For this question here, it says, given the graph below, determine the equation, then determine what the equation would look like if the value of y equals 3. So you'll recall that our equation for this is y equals a absolute value of x minus h plus k. To get our h and our k, real easy, guys. That is simply our vertex. That is this point here. What is our vertex? At 4, 0. This is our h, this is our k. So right now we would have y equals a absolute value of x minus 4 plus 0. Okay, not a big deal there. And you can actually get rid of that 0 if need be. Now, what about a? So a is like our slope here, okay? A is our change. So if a is like our slope, or our rate of change, this is the same thing as like our rise over the run. And I know in 8th grade, for sure, you were able to determine rise over run given 2 points. What was my rise? So I have this other point, this 0, 5. My rise here is what? 1, 2, 3, 4, 5. Okay. So we have a change of 5 is my rise. And my run is 1, 2, 3, 4. And you're probably thinking, well, sir, like we went down, so wouldn't this be negative? And my answer to you is, it's not going to be negative, because if this was negative, we would have a reflection and the graph would be going down. Okay, remember this is an absolute value function, and once it's negative, it means that the graph is pointing down. It's no longer in the shape of a V. So knowing all this, my equation is now y equals 5 over 4 absolute value of x minus 4. Okay, you can put the plus 0, it doesn't really matter. And then lastly, it's saying, well, what would the equation look like if we had to solve for x when y is equal to 3. That's there in the equation. So to do that, we would simply say, well, it'd be 3, right? Because y is equal to 3 equals 5 over 4, absolute value of x minus 4. And this would be our answer. We don't need to solve it. I just want to know what is the equation going to look like if we needed to solve for x by hand. So the skills here is, one, you need to be able to identify the vertex, and that is your h and your k. And then to get your a, okay, to get your a value is going to be the change of your rise over the change of your run. Okay, and you'll always be given 2 points to do that. Okay, I want you guys to apply the same skills here. You're going to come up with your equation. Okay, and I'll get you started. You want to make sure that you're using the correct vertex form of the absolute value, which is y equals a absolute value of x minus h plus k. Remember, your h and k come from your vertex, and then to get your a, you would use the change of y over the change of x, or the change of your rise over the change of your run for your 2 points. Be careful, you shouldn't get a negative a, because we don't have a reflection. But go ahead and do that. If you have any questions, let me know. All right, and so lastly here, guys, this is a nice little review here to get us started with our free response. Okay, there's actually 1, 2, 3, 4, 5 questions that I'm asking you here, and it's all analysis of a graph. On your free response, I'm telling you, you're going to get this crazy word problem, and these are the skills that you need to do it. Like, don't let it all psych you out. We've done so many word problems already, and I just want to make sure that we identify the skills. So for our vertex, determine the vertex. Let me do this real quick. You guys are pretty good at it. We see this here. Here's our vertex, 8, 1. You're going to be asked to identify the vertex, but it's going to be like a crazy question. Like, but that's all you got to do. Identify the vertex. For the equation, okay, I want to come up with the equation for this, okay? Just like we did in the other question, we're going to use that vertex, okay? So we have y equals a absolute value of a x, oops, sorry, it should be an x, okay, minus h plus k. Well, we already know the vertex, right? So like when we did in the last problem, we just plugged that in. We have y equals a absolute value of x minus 8 plus 1, okay? I need my a value though, my change. Well, I'm going from 0, 9, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. I'm going down 8. So my a value right now is equal to 8 over 1, 2, 3, 4, 5, 6, 7, 8. Absolute value of x minus 8 plus 1. And you can reduce that absolute value, I'm sorry, not the absolute, the 8 over 8, okay, to 1. So we can say y equals 1 absolute value of x minus 8 plus 1. And this is our equation. Okay, what about our range? And you'll notice here, guys, it's not asking for the domain. We already know, and I've drilled this with you guys, that the domain of all absolute values is always going to be all real numbers. But for my range here, okay, what's the lowest our range value goes? Our point is here at 8, 1. The lowest it goes is at 1. So my range would go from 1 to infinity. Because the lowest it goes is 1, and it goes up forever. Okay. The next, okay, part 4 is what's the y-intercept? This one is super easy, guys. It's actually already in the question. It's right here at 0, 9. Okay. And then where do we have our axis of symmetry? Okay. Our axis of symmetry. This is critical. Remember, our axis of symmetry is always going to go through our vertex. and it's always going to be x equals whatever our x value is of our vertex, which is our value of 8. X equals 8. So again, on your free response, you're going to get an intense question that's going to talk about all sorts of stuff. None of that matters. You need to be able to do these skills, okay, to master that question. So I want you to practice those skills on this slide here. So on this slide here, you guys will go through all the same steps. You want to identify the vertex, it's there. From there, you're going to come up with your equation. Remember, you use your vertex for your h and your k. You'll use the 2 points to identify your a value. Remember, it's the change of your rise over the change of your run. You want to determine the range. It is not, and I'll say this again, it is not all real numbers for the range. That is for the domain. Okay, so your range, remember, it's from your bottom point up. Identify your y-intercept. That's an easy one. It's right in the graph. And then determine what your axis of symmetry is. Remember, it's x equals some value there. It's determinant on your determined based off your vertex. Okay. So guys, this was a long, lengthy review. I know. This is why it's a 2-day review. Please be sure that you complete this review and that you also take the time to study it the night before the exam. If at any point you have any questions, please send me a message on Teams or ask me during class as well. I will be walking around. Great job on this, guys, if you finished up already, and best of luck to you on the exam. I know you guys are going to do awesome. All right, bye.